Hey guys, welcome back. In this video, I'm going to teach you everything you need to know about the parametric equations for your AP Calculus BC, or just if you guys are taking a different course. Okay, so in this video, I'm going to teach you the formulas for them and what you need to know. But if you guys want the proofs, you're going to have to go to a different video for it, okay? So you're just going to basically have to accept the formulas in this video, and if you want the proofs for them, you can go to my other video. So these are the 6 items that you need to know for the BC exam. First, how to find the slope, then how to find the equation of the line at a given time, how to find the second derivative, the speed, the distance, and the position. So let's get to it. How do we find dy dx? Well, it's actually very simple. Take this pair of parametric equations. If you were going to take the derivative of y with respect to t, then dy dt would be 2t plus e to the t. Dx dt would be, derivative sine is cosine angle times 2t. Well, check it out. If you guys divide dy dt by dx dt, the dt's cancel, leaving you with dy dx. So literally, that's all you have to do. You just have to say dy dx is equal to 2t plus e to the t over 2t cosine t squared. Now, most likely they'll ask you at a specific time. So if they said at time t equals, let's say, 1, then you would put a 1 in there. And you can actually just leave your answer as 2 plus e over 2 cosine 1. Okay? Now, typically, these are calculator problems. So that means that they're either number 1 or number 2. So once again, to find dy dx, all you have to do is take the derivative of y with respect to t, the derivative of x with respect to t, and then just divide them. Because dy dt over dx dt, the t's cancel each other out. So that's all. How do we find the equation of the line tangent to the curve at a specific time? Well, anytime you're trying to find the equation of the line, first thing that you need is a point. So what is y of 2? Well, y of 2, because remember this is t, this is t. So y of 2 is going to be 4 plus 2, which is 6. What is x of 2? X of 2 is going to be 6 minus 4, that's 2. So at time t equals 2, the particle is at position 2, 6. Now, what is the derivative? Because we need the slope of the line tangent to the curve. So we just found it in the last page. So how do we do that? Dy dx is equal to dy dt over dx dt. And that's very simple. You just say the derivative of y is 2t plus 1 over the derivative of x, which is 3. You plug in, remember, this is a t, so you have to plug in the t. And that's going to be 2 times 2, 4 plus 1 is 5, and then you get 5 thirds, and then you just say y minus the y is equal to m times x minus x. And then you could just leave your answer just like that. If I'm going too fast, slow it down, and but it's pretty basic. How do we find the second derivative? So I'm actually going to show you why this is in a different video. But for now, I just want you to know how to get it. So if you want the proof for this, just watch my other video on proofs of parametric equation. Okay? So how do we do this? This is going to be a little bit different. First thing, to find the second derivative, what you're going to do is you're going to take the derivative of the first one with respect to t. Now remember, when you took the derivative of dy dx, okay, it was in terms of t, 2t plus 1 over 3. It was, before I did it here, it was in terms of t. So, because it's in terms of t, you're going to take the derivative of dy dx by itself. So you're just going to take the regular derivative of the first derivative. However, and again, I can show you this in the proof video, you have to divide it by the derivative of the x, okay? So in this example here, the derivative of this guy, I'm going to do x prime of t is 2t. The derivative of this person is 2. So therefore, the first derivative is going to be y over the x1, and so you get 1 over t. Now, we know that this could be t to the negative 1. So what do we do to find the second derivative? So d2y over dx squared is going to be the derivative of this, which is negative 1 t to the negative 2, divided by the derivative of the x, which is 2t. Okay, I'm going to leave it like that, but I just wanted to show you how to do it. So you take the derivative of the derivative, and then you divide it by the derivative of the x with respect to t. Okay, so that's how you find the second derivative. It's not frequently asked, but it does pop up here and there. Here are my other two formulas, and that you guys definitely need to know for this. It's the speed and the distance, and it's actually really simple to see it. It's like a vector, right? And it's like a squared plus b squared equals c squared. So the speed formula is going to be the square root of the derivative squared of x plus the derivative squared of y. Okay, so take the derivative of x and square it plus the derivative of y and square it. And that's how you get the speed. If you integrate this, you get what we call a distance and an arc length. Once again, I will prove this in the proof of parametric equation formula video. The next two items that we need to do is the position. And how to find the position at a certain time is rather simple. They have to start off by telling you where the particle is at a certain time. So then all you have to do is say, okay, I'm right here. And they basically have to tell you where you need to end up. Okay, so they can say at time t equals 0, x is at 5, and y is at 3. Where is the particle's position at time t equals 1? So you say, at time t equals 0, I'm here, plus the time 0, so a to b, the integral of the x, because you want to know where you are in the x direction. So just x prime of t, and then where you are right now for y of t, so where you are plus how much you traveled. So same exact thing. And so with that being said, let me just show you a quick example of AP problem. I can choose this one here, the 2016. It says here is y of t. It says at time t, the position of a particle moving in the y plane is given by the parametric functions x of t plus y of t, where dx dt is t squared plus sine 3t squared, and the graph of y is shown above. At time t equals 0, x equals 5. At time t equals 0, y is equal to 1. That's important because they always ask you for the position. They typically ask you for either an x or a y, but in this case they said find the position of the particle at time t equals 3. All you have to do is say right now in the x, so they want at time t equals 3. So all you have to do is say at time t equals 0, I'm going to be at 5 plus how much I travel from 0 to 3 of dx dt. Okay, I need a calculator for this. I'm not going to do it, but that should give you x of 3. Okay, and now y of 3 is going to be, y right now is at 1, and then you need from 0 to 3 dy dt, right? And so from, you're going to have to figure out the integrals is basically area. That's going to be from here. So this should cancel this out, so you can have a negative. So that's negative 1, and then this is 1 by 2, and so 1 by 2 divided by 2 is a negative 1 also. So together that makes negative 2. So you're going to get 1, negative 2. I may have messed up something there, but basically you're going to have to integrate and find the area from 0 to 3. I think that's going to be probably 1.5, I think. Okay, something like that. So here we go. X of 3 equals x of 0 plus from 0 to 3 of x prime of t. And y of 3, I'm being silly right now. I'm not thinking. Y of 3, this is the y function. So y of 3 is just the value, and you're going to estimate it at negative 0.5. My apologies. I totally forgot that wasn't dy dt. Okay, so that's one of them. The slope is going to be very, very simple. To find the slope of the tangent line, you're basically going to take this at time t equals 3. You're going to take dy dx is equal to dy dt over dx dt. And so the slope at 3 here is going to be positive 1/2. And then the slope here is going to be at 3, it's going to be like 9 plus sine 27. So basically you take the derivative of y, derivative of x, and I'm just trying to get through the video quickly so I don't waste anyone's time. The next one is the speed. So the speed is going to be, speed is equal to dx dt squared plus dy dt squared. And you will find that you would need a calculator at time t equals 3, which is fine. And then the total distance is the integral of it. So basically, guys, that's what we need to know for all of these problems. Position, slope, speed, total distance. And once again, position, speed, total distance, it doesn't matter. Line tangent to the curve, you're probably talking about the slope. And once again, all of these are position, speed, distance. Every single problem is exactly the same. So I hope this was helpful, and we will try more problems in different videos.